I have always been curious. The ship's propeller is underwater, and the propeller shaft passes from the engine room through the hull to transmit power. So how does it achieve sealing and prevent seawater from leaking into the engine room? In the early days, the stern shaft sealing design was relatively simple. It used packing seals. That means wrapping rings of oil-soaked asbestos or hemp rope and pressing them tightly around the shaft. By adjusting the tightness of the gland, a seal was formed. But the disadvantages were obvious. Friction was high, wear was fast, water leakage was common. Especially during high-speed sailing, the sealing performance was even harder to guarantee. So this method was gradually eliminated. At present, the most commonly used stern shaft sealing structure on ships is the lip-type seal. Now let's see how it works. A typical stern shaft sealing system usually includes the shaft, the stern tube, the sealing device, and the lubrication system. The stern tube is usually welded directly to the hull. The sealing devices, such as the lip-type seal, are located at both ends of the stern tube. They are divided into the forward seal and the aft seal. Now let's focus on the forward seal. The lip seal consists of multiple rubber sealing rings arranged in order inside the sealing housing. There is a spring embedded inside each sealing ring. It provides continuous pressure to keep the ring tightly pressed against the shaft. Each sealing ring looks like a lip. That is how it gets its name. The spaces between the sealing rings are called intermediate chambers. As shown in the diagram, there are 5 chambers in total. When working underwater, the first outer lip seal tightly contacts the rotating shaft. It blocks seawater from entering. But facing strong water pressure, this alone is not enough to completely stop seawater from seeping in. So slightly higher air pressure than the water pressure is injected into chamber number 3. The lubricating oil pressure in chambers 4 and 5 is slightly higher than the air pressure. In this way, the air pressure is transmitted through chamber number 2 to chamber number 1. This pressure difference helps prevent seawater from flowing back into the sealing chamber. It also helps maintain the elastic contact force of the sealing rings. It prevents the sealing rings from loosening due to external pressure changes. And it ensures long-term sealing performance. The lubricating oil has 3 functions. First, lubrication, which reduces friction between the sealing rings and the shaft. Second, cooling, which carries away the heat generated by the rotating shaft. Third, isolation, which uses pressure difference to separate seawater from the inside of the ship. The second lip seal mainly prevents oil from leaking outward, and together with the first seal, it forms an oil sealing chamber. If a small amount of seawater and lubricating oil leaks into chamber number 3, the flowing air will carry the mixed liquid away. It then enters a collection tank for separation. You may notice that in front of the first lip seal, there is also a P-type sealing ring. Its main function is to prevent the sealing system from being damaged by fishing nets and fishing lines. That is the working principle of the stern shaft sealing system.